Alright, for today's lesson, we are still in Module 1. We are now in Lesson 3, where we're going to use exponents to name place value units and explain patterns in the placement of the decimal point. Let's start with a fluency. They gave us a number in unit form, and we're going to state how to write it as a decimal. So if I start with 9/10, remember your decimal place values. Your decimal place values are tenths, hundreds, thousands. Tenths is the first place after the decimal. Hundreds is the second place after the decimal. Thousands is the third place after the decimal. So if I have 9/10, the word tenths means I only need one decimal place, and 9 is going to sit in that place. So I would write 0.9. So 9/10 in standard form is 0.9. Now we have 10/10. Notice we still have tenths, which means I only need one decimal place, which means only the 0 can sit in the tenths place. That 1 has to shift to the ones place. So 10/10 would look like 1.0. Only one digit can sit in a place value. So the 0 got to stay in the tenths. The 1 had to shift next door. Tenths means I need one decimal place. This 1 gets to sit there, which means this 1 has to shift. So 11/10 would be 1.1. Once again, we have tenths, which is 1 that's first decimal place after. The 2 gets to sit there, which means the 1 has to shift. So 12/10 would be 1.2. Tenths, the 8 gets to sit there. So 18/10 would be 1.8. So one more. Tenths, the 8 gets to sit there. So 28/10 would be 2.8. So just keep in mind that our decimal place values are tenths, hundreds, thousands. Now let's get into our lesson for today. We are writing using exponential form. Notice I started with the number 10 in standard. The next thing I want us to write is a multiplication sentence for 10. So if I got 10 times, what would I put in the blank to make it equal 10? Well, we should know that 10 times 1 will give us 10. Keep in mind that anything times 1 stays the same. Any number times 1 stays the same. So now if I want to write it in exponential form, that means I need a base number and I need an exponent. So my base number, of course, is 10 because we are working with powers of 10. My exponent for this would be 1. I want you to work along with me and see if you can come up with the pattern for the exponent. Remember, my small number to the top is my exponent. I want to see if you can figure out what determines my exponent without me just telling you what it is. So let's go to 100. This time I want a multiplication sentence, but we're only going to use tens because we're working with powers of 10. So I need a multiplication sentence using only tens that will equal 100. Well, hopefully you're saying that 10 times 10 would give me 100. And now I need my exponential form. Remember, our base number is 10 because we're using powers of 10, and I need an exponent. What could my exponent possibly be? I hope you said 2. You are correct. So 100 is equal to 10 times 10, which is also equal to 10 to the power of 2. Let's move to 1,000. You know I want a multiplication sentence only using tens that equal 1,000. Hopefully you said 10 times 10 times 10. Our exponential form would be, my base number is 10, because we're working with powers of 10. And my exponent would be 3. I'm hoping you're starting to see what tells me what my exponent. There's something that clearly tells me my exponent. Now let's go to 10,000. I want a multiplication sentence using only tens that equal 10,000. Hopefully you figured out the pattern and know that it's 10 times 10 times 10 times 10. And our exponential form would be 10 to the power of 4. So hopefully we now know the pattern. If you're looking at the standard form of the number, the zeros tell you your exponent. Meaning, 1 0 in my number, my exponent was 1. 2 zeros in my number, my exponent is 2. 3 zeros in the number, my exponent is 3. 4 zeros in the number, my exponent is 4. Let's say I did not give you the standard form, I only gave you the multiplication sentences. Well, the number of tens now tells me my exponent. In my multiplication problem for 10, I only see 1 10, so my exponent is 1. I see 2 tens, so my exponent is 2. I see 3 tens, so my exponent was 3. I see 4 tens, so my exponent was 4. So, to figure out my exponent, all I have to do is count my zeros or my tens. Each 0 represents a 10. Each 10 represents a 0. Okay? So let's say we have 100,000. Well, we know now that we see 5 zeros, which means I also need 5 tens. So 10 times 10 times 10 times 10 times 10, which also means my exponent has to be 5. 5 zeros, 5 tens, exponent of 5. What if we had 1 million? Well, you should see that there's 6 zeros, which means we need 6 tens. And we have an exponent of 6. So remember, my zeros will match my tens, will match my exponent. If my exponent is 5, I need 5 zeros, I need 5 tens. If my exponent is 3, I need 3 zeros, I need 3 tens. That's how our exponential form works. Exponential form is just a shorter way of writing standard form. Instead of writing all these zeros, I can simply write 10 and let you know that it's million because it's 6 zeros. Now this time, I'm giving you the exponential form. Can't take that off. 10 to the power of 5. Well, if I asked you to give me the multiplication sentence, you should know how many tens I would need. Right, I need 5 tens because 5 is my exponent. So 10 to the power of 5 would be 10 times 10 times 10 times 10 times 10. Remember, my exponent has to match my number of tens. If I asked you to write it in standard form, you should know that my answer would be 100,000. 1, 2, 3, 4, 5. Because if I have an exponent of 5 and I have 5 tens, that means in my standard form I need 5 zeros. Remember, each 10 represents a 0. They have to match. Okay, let's try another. What if we had 10 to the power of 3? What would my multiplication sentence be using only tens? Right, 10 times 10 times 10. And what would our standard form be? 1,000, because 1,000 has 3 zeros. Notice my exponent matches my number of tens, matches my number of zeros. 3 zeros, 3 tens, exponent of 3. Okay. Now let's use this exponential form to answer a multiplication sentence. Notice this time I have 10 times 100. Well, if I asked you to write that in standard form, we learned in 4th grade that powers of 10 can be multiplied by doing your basic fact, which is 1 times 1, which equals 1. I have 3 zeros in my problem, so I need 3 zeros in my answer. Okay. Well, I just taught you how to write that standard form in exponential form. So what do you think the exponential form for 1,000 would be? It would be 10 to the power of 3. Notice my zeros still match my exponent. In my problem, I have 1, 2, 3 zeros. In my standard form, I have 1, 2, 3 zeros. In my exponential form, my exponent is 3. They all match. Let's try another one. Let's say I have 1,000 times 100. If I ask for the standard form first, we know we're doing basic fact, which is 1 times 1, which equals 1. Now we know our problem has 1, 2, 3, 4, 5 zeros, so my answer needs 5 zeros. So there's our standard form. And then if I asked you to write it in exponential form, you should know that your exponent is 5 because we have 5 zeros in the problem, 5 zeros in my standard form. So my exponential form will be 10 to the power of 5. Okay. Now let's start working some problems like the ones we did in lesson 1 and 2. But instead of me writing my power of 10 in standard form, notice I've now written them in exponential form. My steps do not change. So 3 times 10 to the power of 2. Let's start by writing it in standard form. Well, the 3 is already written in standard, times 10 to the power of 2, which we just learned. My exponent tells me I need 2 zeros. So that number would be 100. So 3 times 10 to the power of 2 is the exact same as 3 times 100. That goes back to that 4th grade skill. To solve it, I'm going to do basic fact. 3 times 1 is 3. Add 2 zeros. 1, 2. So 3 times 10 to the power of 2 equals 300. Okay. Now, the reason we're able to do basic fact add zeros is because this first number is a whole number. Notice for this next problem, I got 3 and 4/10. This is not a whole number, so you can't just do basic fact add your zeros. This is where what we learned in lesson 1 and 2 comes in. I'm going to draw a place value chart. Anytime I need a place value chart, I can simply draw one. A place value chart is a rectangle divided into place values. I'm going to write my decimal right here because I only need one decimal place, but it really doesn't matter where you put your decimal. So 3 and 4/10. Remember, we learned that when we multiply, we're shifting the digits to the right. My exponent tells me how many times. Because remember, if I wrote 3 to the power of 10 in standard form, that would give me 1,000, which is what we did in lessons 1 and 2. So I know my digits need to shift to the right 3 times. So my digits are shifting to the right 3 times. So I'm going to take my digits and move them. 1, 2, 3. Oh, wait. I don't like that ideal. I like to bring that down. So we're going to erase that and do that over. I don't like that at all. Okay. So going to shift to the left 3 times. 1, 2, 3. 1, 2, 3. I'm out of digits. My decimal is all the way down here. What did we learn in lessons 1 and 2 to do to get us back to that decimal? Simply add zeros. So I'm going to add my 2 zeros. So I know that 3 4/10 times 10 to the power of 3 will give me 3,400. Remember, when I have a whole number times the power of 10, I can do basic fact, add zeros. When I have a decimal times a power of 10, I have to shift. I have to shift to the left 3 times when I have an exponent of 3. So, whole number, basic fact, zeros. Decimal, I have to shift. Okay. 700 divided by 10 to the power of 2. Let's start by writing that in standard form. Well, we know 700 is already in standard. Divided by, and we just learned that 10 to the power of 2, my exponent means I need 2 zeros. So I'm dividing by 100. Okay. So, I'm going to draw a place value chart just because I like place value charts. Remember, that's simply a rectangle, and divide your rectangle into place values. I'm going to put my decimal right here so that I have tenths, hundreds, and thousands. I'm going to write my number in my chart. So I need 7 in the hundreds place, 0 in the tens, 0 in the ones, 700. Okay. I'm going to extend it. So that I can do my work. We are dividing. Remember in lessons 1 and 2, we learned that division takes us to the right of the place value chart. I have an exponent of 2, which means I have 2 zeros, which means I'm shifting 2 times to the right. So I'm going to take my digits and shift them 2 times to the right. 1, 2. 1, 2. 1, 2. My decimal is inside my number, so I don't have to add any zeros. So I know that 700 divided by 10 to the power of 2 will give me 7. Now we have a pattern to complete. I'm going to use this place value chart to help me figure out my pattern. So I'm going to start by putting this number in my chart. So I got 0 ones, 0 tenths, 4 hundredths, 3 thousandths. Okay. Notice we moved to now the 4 is in the ones place and the 3 is in the tenths. So I'm noticing, give me that back. I'm noticing that my digits, they shifted to the right and they shifted 2 times. We learned in lessons 1 and 2 that when we shift digits, I might have said the right, but I meant the left. We shift into the left 2 times. We learned in lesson 1 and 2 that when we shift to the left, we are multiplying, and that 2 tells me how many zeros I need. So basically, this is showing me my pattern is I'm multiplying by 100 each time. Okay? Multiplying by 100 each time. So I'm going to draw another place value chart to help me figure out my next number. So in my chart, I'm going to just continue this one. That's the easiest thing to do. Okay, so I'm going to start with 430. Notice here's my decimal. So I need 4 in the hundreds, 3 in the tens, 0 in the ones. Remember, we're multiplying or going left 2 times. So I'm going to take my digits, 1, 2, and fill them in. 1, 2, 1, 2. I got to get back to that decimal, which means I need 2 placeholders. There's my missing number. So in that spot, I've got 43,000. Okay. So now, starting at 43,000, I need to multiply by 100 again, because remember, that's our pattern. For us to get from here to here, we did times 100. From 4 3/10 to 430 times 100. 430 to 43,000 times 100. So to figure out this missing place, we got to still do times 100. So that means I got to shift left again 2 times. So I'm going to take my digits and move them 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Notice I'm not at my decimal, so what do we need? Placeholders. So I'm going to add my 2 zeros, which now gives us 4,300,000. Okay, so we found our pattern. First thing I did was put my first number in my place value chart, put my second number in there, and I figured out, did I shift to the right or did I shift to the left? Well, I noticed my digits shifted to the left. Then I said, how many times did they shift? Well, they shifted 1, 2. So if my pattern is going left 2 times, we already learned that left is times. My number tells me how many zeros I need. So that means my pattern is times 100. So I did times 100 to each number to get to the next number. Times 100 to get to the next number. And I continued to do that till I found my 2 missing numbers. Okay. So that is our lesson 3. In lesson 3, we use exponents to name place value units and explain patterns in the placement of the decimal point. Some key points to remember is that my number of zeros tells me how many tens I'm multiplying. It also tells me what my exponent will be. Also remember that when we multiply, we're moving the digits to the left on the place value chart. When we divide, we're moving the digits to the right on the place value chart. All right, I hope this lesson was helpful. And until next time.